So today we're going to look at evaluating a mixed circuit. So we're not going to have just a series circuit. We are going to have a mix of series and parallel resistors, and that might confuse some people. And it can be really, really simple if we just make sure that when we make a decision on doing some math, that we have either just all series or all parallel. In this case, we can't, for this circuit I just drew, we can't evaluate anything until we simplify it. All right, it cannot be mixed when we start applying some of our rules. So I'm going to make this 120 volts. All right, kind of like household. This is, I just drew a battery. I did not draw alternating. We don't care about that. And I'm going to label, what color do I do? Let's use red. I'm going to label these. I'm going to make this one 6 ohms. I'm going to make this one 12 ohms. I'm going to make this one 6 ohms again. And this one is going to be 5 ohms. Okay, now many times if we have a circuit and we want to find out lots of information, in this case, we want to know 3 things about every point. We want to know resistance, current, and voltage. And so a chart like this with the 4 positions, if you want, I can mark these for you so you know what's what. This is position number 1. This is position number 2. This is position number 3. And this is position number 4. All right. And so let's start this chart. And then we can feel like we actually know something. What do we know? We know position 1 is 6 ohms. Then we have 12 ohms. I guess I should put the little ohm symbol. And then another 6 ohm. And then 5 ohms. We don't know the total yet. We're going to figure that out. You can't just add those up because, again, there is a parallel mixed with series. But we do know the total voltage. From one end to the other end, we know there is a voltage drop of 120 volts. And when we say voltage drop, it means one side is 120 and the other side is 0. Okay, so if you wanted to think about turning this on its side, that here is 120, here is 0, and the electricity has to drop from one end or from a high potential to a low potential. All right, so what do we want to do? We want to first simplify before we start to try to do anything else. So I'm going to turn this picture. I'm going to get one thing out at a time. And I think the first thing we need to remove is that scary parallel section. So we're going to turn it into this where we know this one is still 6 ohms, and we know this one is still 5 ohms, but we want to figure out what this is. And we can do that because the 12 ohm and the 6 ohm were in parallel. And we know our rules for parallel is 1 over R total or R equivalent equals 1 over the first resistor plus 1 over the second resistor. So we know 1 over the mystery number is 1 over 12 plus 1 over 6. And we know that remember when you had fractions back in 4th and 5th grade, the 1 over 6, you have to have a common denominator. So that's 2, if you can imagine this is 2 12ths plus 1 12 is 3 12ths. And then we know if we solve for R, we take the reciprocal 12 over 3, which is 4. All right, now you know why I pick those numbers, because it is nice and convenient. So now we know that is 4 ohms. So in this picture, and I'll make sure to label this we knew was 120 volts. This is already a much simpler picture, and it's not as scary to look at. But let's make it even easier. So we're going to reevaluate this picture again. And since now it is all series, we can replace all 3 of those resistors with just one resistor, one equivalent resistance. And since it's in series, we know the rule for series is that R total is just R1 plus R2 plus R3, etc. So we know we can just add 6 and 4 and 5. And so our total is a convenient 15 ohms. You see, almost all the numbers here are pretty decent and nice to look at. And then I'm going to relabel this so we have everything in our picture here. Okay, so now this picture everyone can solve. We have 120 volts total, which I've already written here. Let's go, and every time we find out a piece of information so exciting, we can write in here and we feel like we're really making headway. So I know we have 15 ohms, 120 volts. Well, whenever we know resistance, we know two of our three things in Ohm's law, we can find the third. So right now, how about we evaluate that last little component from that line, and that is current. And we know I equals V over R, Ohm's law. And so we have 120 volts, and we are going to divide that then by our 15 ohms. And if we do that, what do we get? So we get 8 amps. So we can go add that to our chart. There's our 8 amps. And I'm going to label it in this picture. In here, we have 8 amps of current flowing in this picture. Well, what about, let's go back. Now that we know everything about this most simplified picture, we're going to go to the medium picture. And what do we know? Well, this is series, and we know in this picture, there is only one pathway. And if we only have one pathway, everywhere in this picture would get 8 amps. Well, that's very convenient because now we know this first one that we can label this 8 amps, 8 amps, 8 amps. How exciting is that? And since this is position 1, we know my 6 ohms here has 8 amps of current going through it. So I'm going to label that right there, 8 amps. I know position 4 exists in my original picture, so that 5 ohm in position 4 also has 8 amps. How exciting is this? So we know a lot. All right, now that we know that, we have two things again. We have current and resistance. And if we have current and resistance, it allows us to find voltage. So I'm going to draw a little line here so we know where that comes in. And I want to solve for voltage now. And I know V equals I times R. And so I know that I have 8 amps times 6 ohms, right? And knowing that, I know there are 48 volts from here to here. So a voltage drop. So I can label it here if you'd like. 48 volts. Oops, sorry, my 8's bad. And that's from here to here. There's a voltage drop. And I'm going to label it here. We have 48 volts. Great. All right. How about for this position? Let's do this position right here. Right? So we know V equals now 8 times 5. And if we do that, we have 40 volts. All right, so I'm going to label this 40 volts. All right, look at this. We're almost done. Don't you feel good now? So I'm going to label this 40 volts if you'd like. Now, what about here? Why didn't I do this one? We can do this one. It just is not in this picture here. And so we'll have to see how that relates. So let's do this one more time. Okay, sorry, a little arrow is going everywhere. So V equals I times R, so 8 times 4. If we do that, we get 32 volts. And now where is that 32? So this is the question. 32 is right here from this position to this position. And so this is 32. All right, that's 32 volts. So who gets the third? So basically, if you want, you could have drawn, if you want, here's that parallel section, right? where we had 12 ohms, we have 6 ohms, right? And we can just pretend those other things don't exist. We can say 32 volts. And couldn't you evaluate this? And we can. So the question is, where is the 32? Do I take the 32 and give 16 to the 12 ohm and 16 to the 6 ohm? And remember the rules for parallel. Do you understand that this side right here is 32? Right here is 0. They both get 32. So I'm labeling as 32 volts and 32 volts. All right, it is not in series where there's a voltage drop in series. There is not a voltage drop in parallel. So I'm going to go up here and say, hey, you get 32 volts and you get 32 volts. All right, now when you see this voltage, you can't just add all these up to get 120 because these are both 32. It's kind of like a stream falling, and it fell through a height of 48, but then the stream broke into two and split, and there's still just a height of 32, but they're both going at the same time, and then they come together and drop another 40. All right, so 48, 32, and 40, yay, equals 120. That all works out. Now we have one last thing to evaluate. The last thing you ever find always is the current in a parallel section. So let's do that. So we know I equals V over R, and I have my V is 32 and my R is 12. And when I do that, I get, this is our only not so nice answer, is 2.7 amps. And then when I do it for the 6 ohm, I'm going to get 32 over 6. And when I do that, I got 5.3 amps. Okay, so I'm going to label this. And so let me put it in the right place. So we have 2.7 amps and we have 5.3 amps. And hopefully you see something that's important here. And that is that when we look at evaluate our currents, we had 8 amps. Here, I'm going to go back to my first picture. We had 8 amps right here. Then it split, right? Some of the current went this way. Some of the current went this way. 2.7 went one way. And where did the 2.7 go? The 2.7 is the smaller amount. Why is 2.7 this? Why does the 12 ohm get 2.7? Because it is a higher resistant path. So less current is going to go that way. More current is going to go through the 6 ohm resistor. And what do you notice? The 2.7 and 5.3, when they come together, what do they make? 8 amps. So we are definitely consistent here. We started with 8 amps. It split up, came back to 8 amps, and so it is uniform. So when we evaluate this, it looks like all these numbers seem to make sense with our totals. All right, and the lesson to be learned here is you start with a complex circuit, you simplify it, you simplified it again following the rules of series and parallel. You find out everything you can about the simplest circuit, and then take some of that information, apply it to the medium complex circuit, and add in some detail, find out more information, and then apply that to your original circuit so that you can evaluate and find out everything you need to know. All right, hope this example helped, and happy circuits.